So what is your personal opinion? How hard should it be to set up a pipeline, and how long should it run for a standard web application?
For me, it's within like 10 minutes. I should run completely. Ideally, with also, if you have end-to-end tests, they should also be included there, which also means you should not have a lot of end-to-end tests, but more of a unit integration tests that, and maybe some contract tests that give you good confidence. And I think a pipeline needs to have as much in it as you need to be confident that it works and you can. If you say, okay, no, let's maybe keep it a bit on staging so that we might find bugs accidentally by working on the staging system, that's like hope, and hope is not a good quality strategy.
I'm not going to do any features on this project until I have at least a minimum pipeline. But what is that? Like, when should that intuition be developed, and by whom on the team?
I have a thought on this. And for me, it's also like one of the first things I do when I start a new project is to have this pipeline in place and to have some basic linting, basic checks, have a test framework in there that makes it easy to write some tests. And then I can also, then it is the barrier to writing tests is lower. And often I think that's, and also with the pipeline, the barrier to extending a pipeline is lower than the barrier to creating a pipeline. At least this is my impression from working with teams, that often people don't know what it means to build a pipeline, and they think because they don't know it's something very complicated and that takes a lot of time. And then when they are asked, okay, how long will it take? They say, I don't know, maybe 2 weeks. And then somebody says, okay, then let's not do it now. We don't have time. We don't have 2 weeks for that now.
Hello. Welcome to the 30th episode. Today is all about testing again. Quick update. Adrian got stuck in a meeting. He'll probably join us somewhere halfway to the stream. But today's episode, luckily, was my pick. So I'm well prepared. We're not missing out on the meat, at least. So we'll start with the main course, and then we'll do the starter, and then we'll do the dessert when Adrian joins. Then we'll have the cookie. How's everybody doing? How are you doing? Oh, it's lovely. I did have a lot of fun preparing the presentation for today. So unless we have some technical difficulties because of the size of it, maybe some lag. Okay, so lag and a few typos guaranteed. But otherwise, I think we'll have quite a fun episode today. So today is about the 7 types of tests, really. Tests that make sense. I see a lot of people talk about the mechanical properties of tests, let's say what is it touching? You know, is it the black box? Is it the white box? Is it the gray box? Like all of these like weird metaphors that then ultimately end up not really explaining what the boundaries are, what the test does, what the test doesn't do, and you end up with a lot of developers just either having a unit test or an end-to-end test and not really understanding what the other differences are. And I think that's a shame. And I think having done prep for the episode, I saw how difficult it was to just get like just basic understanding. Just Googling is very difficult. You want to Google what is an integration test, what is a smoke test. Like all the answers you get are like really shit, and I think we can do better. So that's what we're discussing today. There's definitely not going to be any pyramids today on stream. So you might remember, the testing pyramid. I hate the testing pyramid. I hate the food pyramid. I hate the testing pyramid. I think it's a vast oversimplification of a very complex and dynamic system, and it doesn't do anybody any favors. It doesn't do you any favors. It doesn't do us coaches and leads any favors. So yeah, let's dive into it. We had quite an interesting conversation today on LinkedIn. I asked in this post, I'll drop it down in chat. I'm gonna read it out loud. here for you as well on the other channels. I can show it actually. Yeah, I can open it in the other tab and show it for you. So I asked my LinkedIn audience just a few hours before the stream, how do you explain what an integration test is? As I did it a little bit tongue-in-cheek, and I encourage people to be funny about it or to be humorous about it. So that would be my question for you as well. For our live audience, how do you explain what is an integration test so that your peers will agree with you with the definition? Right? I don't want an integration test. Well, I think it is this because unless, but it depends, right? So I don't want the unless and exceptions and it depends. I just want the definition that you're comfortable with, that let's say at least your team who knows what you're working on would agree with. What do you think that is? I dropped it for you in chat. Feel free to share it, respond to it, reply to it. If the platform allows, on LinkedIn or on Twitch, on YouTube, don't worry, I'll connect the threads together. So that's that part. Yeah, we usually have like a 5-minute delay on chat, I think. So it'll come when it comes. But I can see we have at least 30 people live, 3 here, 7 there, 21 here. Yeah. So those of you who are bold enough to voice your opinion, I would invite you to openly join the discussion, and maybe we'll learn something new. For those of you here who just want to listen, like just passively participate, it's also fine. You're also very welcome. If you're watching the recording, thank you for being active. If you happen to be watching the recording on the podcast or the stream, please remember to like this, share this, subscribe. If it serves you, if you would like to tell your friends, or if you would just like to stay up to date. What you will be able to learn today is how to deal with legacy systems that are untested, which is the vast majority of the code that you'll be working on. Like usually when I talk to devs, until a certain point in their career, all code was like this. And then it's up to them to hold a standard and basically force higher quality into a new environment that they might join that doesn't have this, or they would always selectively only pick environments where that is already the case. Me as a coach, I've picked a mission to serve those who struggle with this decision. Basically, that echoes the thoughts that you just saw in the preview clips of somebody has to make the bold move of saying, hey, like we need to create a pipeline, we need to create tests, we need to really take control of how we shape and really what we feed our engineering culture, what kind of quality we feed our engineering culture. Kaloyan, hello, one of our regulars. Legacy systems are not tested. You're singing my song. I would recommend also for those of you who are avid book readers to perhaps join the book club. We have them on slightly different schedules, slightly different days every week, 3 times a week, every month. This month we're reading Team Topologies. So the book club is a unsponsored, free activity for now. I do that sort of as a side hustle, and we do it in a speed reading style. So every now and then we have paid speed reading sessions. We are about to have a vote for the next books for the next 3 months. So if you'd like to join, usually on the Crafting Tech Team's newsletter has the join link in the footer. So if you'd like to subscribe or to subscribe to Adrian, if it serves you, go ahead. The reason I mention this is because one of the, let's say, the books I would cite the most regarding this this lack of cultural excellence, a culture of quality, a culture of observability, And by observability, I don't mean that you can't log. By observability, I mean that you can objectively say, prove whether your system will work, does work, has worked when it was deployed, when it will be deployed, when it will be, in such and such a state 2 weeks from now. The book that I would cite the most on that topic is 𝗪𝗏𝗏𝗺's book, Working Effectively with Legacy Code. And we will also explore a lot of findings that were inspired by the book today in the presentation. So why did I mention this? Michael mentions in his book explicitly that legacy systems have basically 3 properties. It is extremely valuable to the business, because otherwise we're talking about a bankrupt business, not a legacy system, right? So legacy systems are always present when the companies are to some degree successful. Legacy systems are systems that are untested and are hard to change, right? So there's that element of, we have it, it works, it's valuable, and we want to make changes to it and it's really hard, or we don't want to make changes to it and every now and then we're forced to because of how it's set up, right? So it's usually one of those 2 domains. So what you learned today is just the basics of, let's say, from my coaching perspective, me as a technical coach, me as a leadership coach, what I see people use the most time on the testing front. So in small to medium businesses, startup scale-ups. So if you're somewhere between 5 to 80 people in your engineering organization, this is definitely for you. And how to deal with the legacy aspect of it, of maybe we have everything test covered and everything's okay, but maybe some of our tests are useless, or we don't have any tests and it's really hard to start and nobody's bold enough to make the start. And then the last step, which is what is really the replacement for the pyramid, what to focus on, how to focus on it, why is testing expensive, why is software expensive. Kent Beck, just before I started the stream, he posted on his newsletter 𝗪𝗏 a new article about just what makes software so expensive, and he also mentions this in one of the later chapters in the 3rd part of his new book 𝗪𝗏, if you're interested, but that will be sort of more of a tangent for today. So finally, the lag has caught up. Francisco, hello. I've noticed you a few times now. You were here yesterday as well. Thank you for at least showing evidence of becoming a regular. Raul, my team usually assumes integration testing as validating modules, components of the software that are not external to the system. Ooh, hang on. I need to. That's a head scratcher. That are not external to the system. I mean, components we don't own. We usually prefer end-to-end or acceptance tests. Okay, Raul, I need to wrap my head around it. Raul, also a very active regular. Thank you. Thank you for being with us, Raul. My team usually assumes integration testing so the act of integration testing as validating modules and components of the software that are not external to the system, so that are internal to the system. I mean, components we don't own. So validating how you use code that you have installed but you have not written. Is that a fair, did I paraphrase that correctly? Did I capture the right essence of what you wanted to say? Do let me know, because that's definitely up there with all the other definitions. And now for a little bit of fun in the beginning, let's jump into the funny bits. Ooh, okay, that lagged a bit. Okay, now we're good. Let's jump. Sorry, I read LinkedIn in light mode. I don't know if there's dark mode for LinkedIn, but if this is in the middle of the night for you and it just flashbanged you, I'm sorry. So we have quite a few comments here. How's the font size? Font size is probably not very good, right? Let's increase font size a bit. I see. So the column is limited. how do you explain what an integration test is? So same question to my audience. And I see I didn't, that went into the wrong thread. Hang on, this is silly. I meant to post that somewhere else. There we go. Okay. So James Galen says there are integration tests and there are derivative tests. Integration tests will determine how much code you have under the curve. This is how you get good code coverage. Derivative tests will test the slope of the curve your code makes. Are you writing a lot of code or are you removing more than you write? We always want to be writing as much code as possible. There's a common misconception that we should write tests ourselves. No, if we write tests, that is a manual step, not an automated one. Let the derivative integration tools do the testing for you. So Galen, if you're here, I didn't catch the link between all of these statements. If you could help us sort of dig through your thoughts here, that'll be very helpful. Particularly under the curve bit and the not writing it yourself part. Like that's, are you hinting that we need code generation for certain kinds of tests for integration, or are you looking for a more compiler-driven way of coupling or perhaps checking boundaries? Do let me know. I think I caught the gist of it, but I need some help. Raul says regarding his previous statement, how they interact with each other. By external, I mean external services, APIs. Ah, I see. So integration testing is validating modules. So validating the modules that you use that are external, so you communicate with them through the network or some other network-based interface. Particularly about what expectations you have of them. Did I get that right? Thank you, Raul. John mentions a test, and most of them are satire. I do have to warn you, which is why this is fun. A test that is slow, flaky, and only tests a set of components that you think need to be integrated together, but are not overall behavior of the system. So in reality, any random selection of classes and functions that work together that you pick. I love this take because I've seen a lot of tests like this. In a sort of in a non-ironic way, I've seen a lot of companies test like this, where they go in and they say, well, this is a piece of code I don't know how to write a unit test for, so it must be an integration test. So I must have an integration test for it in my unit testing suite, whatever unit testing means. Milan says it's okay to use in-memory DBs for integration testing. Again, bit of a sensitive topic regarding is the boundary for integration, not even for being an integration test, but rather where is the boundary to a unit test or developer test, as I would recommend that you perhaps start rephrasing certain kinds of tests as developer tests instead. Is it still, in 2000, in the early 2000s, 20 years ago, 25 years ago, this made sense because everything that wasn't running in memory was slow, extremely slow. But nowadays you can spin up whole databases in memory. Nowadays you have fully fledged SQL databases which are not SQLite running in your memory space, and you can even spin up a Docker container and have a sub-second startup for quite a few services, orchestrated containerized services that you can run alongside your tests. And then, is it a unit test? Is it an integration test? Let's be clear, it's an integration test. But there are quite a few people who say, oh, we shouldn't have that, or we should have that, etc. It can still be an integration test and a developer test, depending on its speed. I wouldn't say it's not a developer test just because it has a database. That's one aspect. Stuart said it's an old wooden ship used during the Civil War era. and my favorite, Rajesh, put another log on the fire, my friends, and draw near as I divulge another secret of our long misunderstood art form. An integration test is nothing but a magical ritual where the oft uttered "it worked in death" is both a battle cry and a lament. It's a rite of passage marking the transition from the blissful innocence of coding in a vacuum to the sobering reality of everything is connected and nothing is simple. It's where expectations meets reality, and they rarely get along. Thank you, Rajesh, for this one. This one's brilliant. This one, but by far has brightened my day the most today. So thank you. Yeah. Audience, if you do like this one, the link to this thread is in the comments. If you scroll up in the chat history a little bit. If you're on LinkedIn, I know LinkedIn live chat can be a bit daunting. Sometimes it just doesn't. I just don't see history sometimes in the client. I don't know. If you go to the link that I originally posted, the one that has the event and /comments, that one will have this kind of format of comments, and you can find it there. Otherwise, the chat just ends up disappearing. I don't know why. I didn't PhD on LinkedIn tech. Kaluya mentions tests that have friends overseas, so I always move on. I like this one. Alexander mentions it's everything but unit tests. It's tests that always break. It's a test that we don't need. I have a lot of wrong answers. Vladi mentions placing an order with first name test and username test. It's test at email.com, test product, test order, test location 1, password test 123. Please change your password if I just said your password out loud. Hazel mentions an integration test is a test so old you don't understand it. So when it goes flaky, you just switch it out. But it's also so big you too scared to delete it in case it's important or you get in trouble. I hate these flaky tests. When I'm coaching teams, flaky tests we aggressively remove from the code base. I'm really religious about flaky tests. You saw me even with Adrian on his pet project. I saw a flaky test. I was like, we're either fixing this or removing it, because it doesn't help me. It pains me to see people I respect, colleagues, friends, mentors, people I coach, to then go into that mental gymnastics of trying to come up with an explanation for a rationalization, to come up with a reason for why they think right now it's okay that their flaky test has failed right in front of me as they were demoing something that was very dear to them. And then they get stuck stumbling over their words because, I'm embarrassed that this happened. Now it usually works. I'm sorry. It's like your mother-in-law comes over and you wanted to clean everything, and she finds that one dusty corner under the couch, and you're like, what happened there? Like, we didn't clean up? Christian mentions an integration test is when you charge a real credit card to test the payment processor. I like that one. A bit tongue-in-cheek. I have seen people do that. When I use smoke tests, I sometimes just say, let's do an end-to-end check. Like, if you have zero trust in the system, let's do a test that hurts to really convince us that it works, right? So let's build a test that will hurt if it fails, so it will take it seriously. And sometimes we do charge a real credit card. I mean, $1 from it, but still. Obviously, you don't want anything charging a real credit card running in your automated testing suite. We call that serverless functions. So use serverless functions instead if you want to burn your credit card every time you write code. Thomas mentions, I would say that it is the test. I would say that it is an integration test if more than one system is involved. Okay, challenge to you. how would you define what a system is? And let me give you an example. I have a Next.js app and has a front end and a back end. Are the front end and the back end separate systems? Or I might have a PHP app, and just by virtue of how it works, it has to store cookies somewhere for sessions to work. Is the part that stores cookies a separate system? The file system, the memory, the shared memory, the cache of any kind, even if it's ephemeral, even if it's SQLite in the local space. You know, what is the definition of a system, right? Because I can play this game all night long. I can play this game and say, oh, an integration test is when I have one integration point and test it, right? But then I need to ask, okay, what is an integration point? Like, what are the boundaries of an integration point, right? So we want to get to the core where my follow-up question, if I were to ask you the same question to that one little bit that we might disagree on, that your answer isn't, well, it depends. Good try. Thank you. I would love to dig deeper into this. We're definitely headed the right. You're definitely onto something. Let me remove the banner because we'll need vertical real estate. I think that's all of them. Let me just quickly check if there's more. Are there any new ones? Yes, there are new ones. Hello, Sanjeev says, it's like expecting a smoothie but forgetting to put the lid on the blender. Integration to check if you're going to enjoy your drink or spend the afternoon cleaning the ceiling. I have used this analogy in the past. This is great. This is great. Thank you, Sanjeev. Let me actually think about it for a moment. So that would mean the smoothie, if you don't put the lid on it, so not putting the lid on it would be the equivalent of what? Of just isolating yourself with either smoke tests or end-to-end tests and unit tests. And it sort of worked in the fairy tale of the isolation boundary. But then when you deploy it, you don't really know whether it integrates with the real world. So it works in the lab, but then when I give it to a user, they're like, they make a mess. Okay, thank you. I will keep monitoring this thread throughout the call. If you get impatient, just drop it in chat, the stream chat. I will now switch over to the presentation. So we will have to adjust zoom size here quite a bit. I helped myself, and I said, if I get confused, I need a starting point. So we have a start here. There we go. That's the presentation. That's the presentation. Let me check real quick whether I missed something. Says Thomas, that's Sanjeev, and the rest is unrelated. Okay. So, topic number 1. What the hell are the 7 tests? And if you came here through the LinkedIn post that announced today's episode, I already told you the 7 tests. And I hope that's what got you excited to come here today. If not, do let me know what of these made sense to you and what didn't. So there are developer tests, contract tests, dependency tests, smoke tests, non-functional simulations, usually Monte Carlo or some kind of benchmark, backend integration tests, and UI integration tests. Do let me know which one stands out to you. Stands out to you as, yes, that one, or stands out to you as, what is this? Or stands out to you in some unknown way, or maybe I missed something. Tell me if I missed an obvious number 8, or if what you understand to be a slightly different test. Obviously, unit tests aren't here. Unit tests are covered by developer tests. I'm just going to say that up front so that we avoid all confusion. And I've deliberately split up two kinds of integration tests. One's where we want to get away from these are orthogonal concepts, right? Integration has multiple dimensions. That's where it's hard to define them. So I've split up the two main dimensions of integration tests. They have nothing to do per se with backend and frontend. So if you run a Next.js app on your backend, and that's running on Node.js on a backend server, that is still a UI integration test. Like that is still that axis of that dimension of separation. It has nothing to do with, I think this third-party dependency management is closest to what Raul mentions an integration test would be, right? So checking that we are honoring some kind of agreement with our external, some API, some other business partners, some SDK, maybe just some static data that we got dumped on us, a database, perhaps a large language model of some kind, right? So I like to say that let's not start with integration tests, actually. I got ahead of myself. Let's start at the top. Let's go clockwise. So I started this thing with two axes: the quality of backend and frontend, and with the axis of infrastructure versus business logic. So it's back versus front on the horizontal axis, and local infrastructure at the top, and business logic at the bottom, right? So your left to right is, let's say, is a specialization of the developer. Top to bottom, the vertical is what you are used to knowing as clean architecture, or the layers of any kind of architecture that has a certain core, onion type architectures or multi-layer architectures where domain or business logic or business information or services live at the deepest layer. So the ones pointing outward with dependencies. Thomas has a follow-up for us regarding my question about what a system is. A system is something that has a different responsibility with different behavior. For example, database serverless functions. In your case, backend with its use case is a system, and the frontend is another one. Yes. So if you want to test the 𝗫𝐸𝐻𝐿 is that an S? Okay. 𝐸𝐻𝐿 from the front end to the back end, then you have two systems. I don't know that. I know it's German, but I don't recognize that word. Is it misspelled, perhaps? 𝐸𝐻𝐿. Pass-through? Is that what it means? Like the pass-through, like the integration? Do let me know how you translate that. Thank you. Thank you for the explanation. Where are we? Okay. I need this one. So on the top, I would start with infrastructure, because that one's the most annoying. Whenever people start testing infrastructure, everybody's like, yeah, but my Lalo and my tests are green and they're pretty, but they don't touch reality. I like to start with reality. Sanjeev, hello. Sanjeev mentioned, sorry, I just joined directly from LinkedIn notifications, so I might have missed the first 20 minutes or so. Just to be sure, do developers mean unit tests, or what is meant in this context? Yes, it is. So it is, I would say, unit tests plus. Unit tests have a very impractical nature to them, because I then have to talk to, if I tell you unit test, your immediate follow-up will be, well, what is a unit? Whereas if I tell you what is a developer test, I can immediately tell you what is a developer test. Because if you ask me what is a developer, well, the tests are the tests. The developer tests are the tests the developer is running on their machine as they're writing code. And that's it's a lot easier to explain compared to unit test. So I starting somewhere around last year, I started adopting the phrasing for developer test to mean everything that happens before commit. Right? All the tests that run before commit are developer tests. tests that I can run continuously on a keystroke. If you've seen me code live with Adrian, we usually have vtest or a continuous test watcher running in one of the side terminals, and it's just constantly barraging us with test results because we're doing TDD. So developer tests are generally all the tests you'd be running in TDD fashion. Great question, by the way, and you didn't miss anything important. I knew it, Thomas. Yeah, durchstick. Yes, so there was a typo. Yes. Walkthrough. Okay, thank you. I still mispronounced it, right? Like, is it durchstich? That's the best with accent pronunciation that I can make. sorry, Germans. I'm glad Adrian isn't here right now. Sanjeev, thank you. So I like to start at the top here. So at the top, I mentioned local infrastructure, right? So smoke tests and non-functional simulations. If you don't have tests, or if you're afraid that your system is just not test covered and you would like to start with something, smoke tests are amazing. Some part of smoke tests are also, if you make them a little bit more complex, a better word for them might be acceptance tests or a certain kind of BDD integration test. Now, it gets complicated very quickly if we enrich all the tests, right? So if I enrich a test with a lot of detail, we will usually come to the same mess. It'll be some derivative of end-to-end test. I just want to put it out there that for every one of these 7, I can say, well, if we add a little bit more detail to it, it'll become some shape of end-to-end test. I just want to put it out there. What's really important is what the language inside the test is, and really who it's meant for, and what the test, particularly what a failing test, is meant to communicate. That is the important bit that I want to separate out here. Yes, if I make a mess, I can always create an end-to-end test out of anything. You can give me a Postman collection, and I can make end-to-end tests out of that, okay? So I just want to put that out there. End-to-end tests are mentioned once in this slide. There is no pyramid, and we will not be talking about a lot of manual testing. If you have to do manual testing, I'm sorry. If you are manual testing, however, you are probably running smoke tests, right? So smoke tests is a test that helps you answer the question, do we understand the constraints of our system? Constraints might be traffic. A constraint might be SSL termination. You know, I need cores, or I need SSL, HTTPS, or I need to pay with my credit card to pay the AWS bill. There are constraints in our system. And the very first sort of integration or end-to-end or whatever you choose, a smoke test or just a curl in bash that you run in your GitHub actions, a ping that you do to the server, whether it's up, a health check. You know, Docker containers can do health checks, Kubernetes can do health checks. These are all smoke tests. They don't tell you that the system works, but they tell you very quickly that the system doesn't work. And in particular, they help you test parts of your infrastructure that tell you, am I capable of detecting that my system doesn't work? It won't tell me what doesn't work if it doesn't work. That's why it's called a smoke test, right? So I use this analogy of, I do have a comparison here regarding the smoke tests. The smoke tests tell you get a fast and early warning for your pipeline, but it's like a gas leak. You can smell it, but you might not know where it comes from. So you need to understand your kitchen, you need to understand your pipeline, you need to understand your system to say, oh, when I smell gas, it's probably that problem that I expect to fail, which is why I have a smoke test for it. Right? So it gives you an early warning that, hey, don't run the integration test for 1 hour because the smoke test is failing. Right? So it's an early failure to tell you, nope, I'm not even starting to build this. Something's wrong here. And something is wrong to such a degree that you're probably able to find out by yourself because we don't have tests, or you need to find out exactly what's going on because our most primitive test failed, and our most primitive test shouldn't be brittle. So go back to the drawing board and redo the code review, redo pairing, redo whatever was changed in this commit message, in this packet of diffs. Something isn't right. Smoke tests are usually such that they are not flaky. Smoke tests are generally very stable, but they do use the network, so sometimes the network doesn't work, which will also tell you something important about your system. So smoke tests failing, you generally take very seriously. These are your health checks and similar. But it can also be an acceptance test of, hey, can I log into the system and do X? Can I log into the system and see this? Can I log in? Is the logo in the certain is in the top left corner? Did the logo load? In a brand agency website, you can make a smoke test of, does the name of the company appear somewhere in the website? Does the logo appear somewhere in the website? Is the dominant color of the website non-white? Right? So is it not a white blank page? These are generally smoke tests. They're not very useful, but they are what you would start with if your team does not have a lot of tests. When I come in coaching software teams, it surprises them that we don't start with unit tests. It's very rare that I would start teaching people how to write unit tests. Ironically, people who are not serious about testing, they want to learn about unit tests and nothing else. So if you want to Google any of these, the easiest to Google is unit tests. Then slightly harder is integration tests. And all of the rest that I have on here on the slides, they are impossible to Google. You'll get no code example. You can try. Tell me if you find any useful code examples or any useful information about what the other ones are. Everybody will tell you that there's a testing pyramid and then there's 15 different types of tests, but everybody will struggle to tell you exactly why it's important, why you need this. And the reality is it's not important and you probably don't need this and you're wasting your time. So these are the ones where I have found from my 2 decades of experience that at least these 7 aren't a waste of your time. Raul, yes, I haven't explained it yet. Quick question. By non-functional simulations, do you mean the app flow? I mean, that concept is not related to smoke tests, which as far as I remember is a functional test type, just confused. No, I would say, for example, a non-functional simulation might be, I will do 1,000 requests on my homepage, and I expect 999 of them to return 200, or one of the cached states. Or I will, generally what you would do as a CDN check, or as a health check, or as an uptime check. Or maybe you have a high-performance system, and you want to Apache bench it, or the one I prefer is artillery. You want to test artillery against it in like a known test bed to check whether performance has degraded. So everything that you would measure on Lighthouse for front end, or on something like Sentry or Datadog for P95 performance, or this idea of misery on the end-to-end side or the front-end side, these are non-functional simulations. One of the aspects, there is also an integration side to simulations, and I have a code example for it down below, which is simulating random number generators. That is an integration concern, but usually it is a non-functional requirement, which is why I put it here in under simulations as well, because the nature of it is statistical, right? So if there's a 0.000005% chance that it can fail, the test is by definition flaky, but we expect the system on the test to also exhibit that behavior, and we say that we have, I don't know, 5 nines. So and the production system, it is expected to be that level of flakiness. So we shouldn't expect 100% when I put it into a unit test, for example. Right? So just to match the cadence of, yes, I don't expect it to be 100% reliable, which is why I have system-wide I have architectural and system design redundancy. So I want to test against that. So I want to simulate it and statistically derive, hey, is this good enough? That's why I call it a simulation, not per se a actual unit test that checks, is random 5 always 5? Because then you have to mock it, and then that becomes a different kind of test. Thanks for the explanation. That makes total sense now. Yeah, so smoke test for non-functional, as it is not heavy as a system testing itself. Correct. It is just saying on the surface, it's, you turn on the car. If I put the key in the car, do the lights turn on? Does the engine turn on? If the answer is no, that's what the smoke test is for. But it doesn't tell you what's wrong with the car. It just tells you that, hey, the car doesn't work. Right? So it's generally anything you would do as check. Right? So, for example, in cooking, Kaloyan, hello, restaurant analogy. In cooking, you have this example of, 1 in 1,000 eggs has that little bit of like bloody like little bit in the egg yolk, which in a normal domestic kitchen you never notice, and you just throw it away. But if you're cracking a lot of eggs in the restaurant and you're pooling them together into 30 egg yolks at the same time, because you're baking, at scale, then if you do 29 good ones and then you add the 30th bloody one, well, that's a huge problem, because now you didn't have 1 spoiled egg, you had 29 spoiled. You have 30 spoiled eggs, and you need to throw the entire batch away. So what they do is they crack it first in a bowl, see if it's okay, and then they put it in. Right? So you don't actually know that the egg is going to be good or not before you crack it, but at least you have some kind of smoke test to say that, okay, well, at the very least, I don't want to make a mess. Same thing with gas leaks. Like the gas and similar things have perfume to them, so that it's not perfume, but they have a smell. They had an added odor added to it, so that you would detect a leak. It won't tell you where the leak is and what's wrong, but it'll immediately alert you that there is one. And I also took a quote from contract testing, actually, and basically it's this idea of, do you set your house on fire to test your smoke alarm? It's like, no, of course not. You test the contract it holds with your ears by using the testing button, right? So the smoke alarm has a beep, 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 and it has a testing setting to say, hey, can you trigger the beep, please? Because I wanna check whether the beeping works, right? So if the beeping doesn't work, then the smoke alarm also doesn't work. And we will come into more detail on this in contract tests, right? So when we are about the system testing itself and the system testing the pipeline, that will be a contract test. Otherwise, we're talking about smoke tests when you're actually testing a production environment. Yeah, just as you mentioned before, like something smells bad at the very beginning. Exactly. So you run your pipeline, you deploy to production, and you say, oh, our early checks, because if you have 1 million tests that tell you all the nitty-gritty details about your system, that actually might take some time to run. But if your website is down because it didn't compile correctly, that is an immediate alert that you can get. Now, you might not be able to derive what exactly is wrong, but you will know immediately that this build, this artifact, is not production viable. That's the point of a smoke test, right? So you want to see that it's smoking, but it's not an inspection, if that makes sense. Let's go back. Okay, so that's the smoke test and the non-functional simulations. They answer the question, do we understand the constraints of our system? Then we have the UI integration tests. I'm going clockwise. The UI integration tests usually tell 2 different things. They tell you, can I separate my system from the framework, right? So can I create a design system that I can separate from the HTML that I'm creating? And can I create behavior that is separate from that design system, right? So one is about behavior, about logic. One is about aesthetics, about how it has to integrate with CSS and HTML. And the hidden axis here is what framework am I using to hide this information? So notoriously, tools like WordPress and jQuery are difficult to work in a traditional manner, in a, let's say, amateur style, because you would be highly coupled to a framework, because the framework helps you separate yourself from HTML. But it will couple your design system with your business logic. And that's the main thing we want to integrate out, right? So that's the main thing we want to separate as separate concerns, and even separate it on another orthogonal axis from the framework. So the UI integration tests help you answer two questions. Can we compose our design system with behavior? And the question of, can we separate outcome from the form of what it is, the form of the component, right? So the component might say, oh, React needs me to create a function that has hooks. Can I separate what it is I'm building from that contract, right? So that the underlying business logic, if there is any on the front end, doesn't have to deeply understand the architectural premise of React, for example. Or if I'm being a little bit more strict here, whatever additional library or framework you're using for state management, for example, or for debouncing, or for rate limiting on the client side, or idempotency, right? Or the fact that you're using fetch or some equivalent to do, or Axios, for example, right? Are you using Axios in a global way? Is it statically bound? Is it injected? Does the business logic not have to know about it, right? So what is the nature of you separating concerns, and how well do you do that? That's what integration tests are for, UI integration tests. UI integration tests generally are a little bit more expensive to build, but they're still your friend, because they are fast and they provide you a reasonable simulation of the UI. So they will produce some HTML. You might even there's an example up on the screen from the work we did together with 𝗪𝗵𝗲 and Adrian. You might actually sandbox it correctly if your CSS and your other accompanying JavaScript is structured in such a way that you can just mount a component and it will render itself correctly, right? So you're not really relying on a lot of CSS inheritance anymore. That your component, your CSS is component isolated, not page isolated. So if you can mount a component in isolation in something like in a design system like Storybook, for example, that you can just pop it in to a test page and say, I can render it and I can test the major behavior, but not anything else. And then how much of your testing code is then coupled to what frameworks am I using? What frameworks am I using for testing? What frameworks am I using for the rendering side? What, et cetera, et cetera, et cetera. How much information, how much knowledge has to be coupled to the main concern that you're testing. So that's UI integration tests. Then going around the curve, there's business logic. Business logic falls into these three types of tests. And they are the same ballpark. Now, why are they the same ballpark? Who had this question? Sanjeev. Sanjeev had this question regarding unit tests. So the primary thing that happens with unit tests is you have to make a decision. I'm touching something that has a third-party API call. I'm testing something that has a database. I'm testing something that has a cache layer attached to it. Am I testing it in full isolation? And then, we are closer to that fairy tale that Rajesh mentioned in his beautifully poetic comment, in that we have no touch with reality, right? So if I isolate my unit completely, a developer test that I would regularly run, I want it to run quickly, but then it also means that I will probably decouple it from all of the integrated systems. Now the issue is, I can run a developer test to check that, say, a entity performs in a certain way when I return it from the repository. It's a lot harder to test a service that way, that does 7 different SQL queries in a non-deterministic way, right? So that the first ones can fail or be flaky, or I will only query the second bit if this is of type admin, or, so that if there's branching logic in the actual querying aspect, if it's imperative, very much imperative, and do this and do that, and maybe if not this happens, do this, then the tests also become complicated, which means that the mocking orchestration, the stubbing, the doubling also becomes complicated. And that's why this is a combination. In developer tests, it's okay that you'll encounter some kind of in-memory test double. I'm not saying mock. Mock has a very specific meaning. I would generally encourage you not to mock things. But you might have a test double. Test doubles are a bit lighter. They might say, I need an interface, I need an in-memory interpretation of it. You create one for the test. Generally, very high-quality teams that perform really well and deploy really quickly and are basically able to decouple a large part of their systems from everything else is they are able to isolate every little bit of the system. But that also means that all of that isolation is fake. It has no touch with reality, because otherwise you won't be able to isolate it. Which means every test double will create two seams of potential problems. One of the seams is architectural, and one of the seams is contractual. Now, let's talk about those, right? So those are the contract test and the dependency test. So the developer test would test the business logic. The contract test would test all of the things that you mocked or doubled or replaced with in-memory replacements, right? So when you create a new mock, let's say it's a third-party system, like Roel mentioned, a third-party API that you consume, that mock now has two endpoints, a consuming side and a providing side. That's a typical contract test, right? So do I integrate with it correctly? Do I respond correctly when it returns something? Do I understand all of the various different things it can return? And then the providing side, which is, if I send you this, you need to send that back. Is that contract still correct? You know, did Shopify change their SDK? Is the interface still working the same way it did when I created the mock? Right, so it always has two elements to it: the server side and the client side, but that can quickly become complicated when you're in a backend system, when you're not in a user-facing environment, right? So let's just say the contract tests test everything you would mock or double or stub for a reality check. That's really important, because the developer tests generally don't have a reality check. And if they're really valuable, they do touch important systems. But then you need to touch, the closer you get to the integrating pieces, you will probably stub them out. And then you need to write tests to check whether the stubs are still following the same rules as reality does. A common problem, you use an SDK, you might have an in-memory, the SDK vendor gives you an in-memory interpretation of it, but as you were continuing to write code, you bumped the version of the SDK. So the tests are still written against the old version, and the SDK was backward compatible. So because you didn't check your contract, the tests still pass, but in production on the newer version, it doesn't pass anymore. That's why you need to have that contract also tested. That's contract tests. We'll go into a little bit more detail later. But generally, it really touches this idea of, do we understand the business problem? These trios of tests tell you, do we really understand what it is we're building? Do we really understand what we control? Do we really understand what we don't control? Is there uncertainty and we handled the uncertainty? Or is there uncertainty and we're sort of hoping for the best and we're not really managing it? So contract tests are these concepts of, I am relying on something external for a reality check, right? So the reality check does not come from me, or the reality check comes from something independent of this team, which might be a second team. So I can, in order for me to independently deploy, I can't orchestrate with the other team. I need to be autonomously be able to tell, hey, does this still make sense? And if they then merge and deploy that newer branch, it still has to make sense. Or something on my side has to fail when I do so, or something on their side has to fail when they do so clumsily, right? So when another team would do a backward incompatible backend change, for example, a contract test will have to fail to alert them that, hey, we use mocks, and the mocks are not realistic if this fails. So if this fails, we need to check whether the mocks, and we probably need to fix the mocks as well, right? So you have this sort of derivative system. This is much more relevant for regulated systems, for fintech, and for sort of data SaaS companies where there's a lot more moving parts across the network with third-party vendors. This is less so relevant for PWA and mobile app development. Just so you have context. If you've never seen this done this way, don't be alarmed. If I speak to 100 developers, 99 of them don't know what contract tests are. So don't feel that you're missing out on something. I'm just mentioning this here so that you have the full picture. This is for your benefit, so that you can sort of articulate and separate out these concepts. But generally, the game you play is essentially, I want to isolate. Isolation means I'm faking the real world, and I faked based on a certain contract. So I need to test. I need to write a test that fails when the contract in the real world changes. So I have some kind of lifeline to the real world that acts like a smoke test, but only for the mock, not for the system. Which is also why I put it closer to the smoke test kind of testing, because these tests can be flaky, and they should be flaky, because they cover uncertainty in our system. Business logic covers certainty, unless it's a random number generator, in which case it's a non-functional simulation. Okay, so this image is starting to make sense on these axes, I hope. Let me know if it doesn't. Then there's the dependency tests, right? So we said that there's two seams of problems that open up when you start writing isolated developer tests. The contract side, right? So you're mocking things. So you're mocking things against an interface or a contract. You need to check the consuming and the providing side of the contract. And then there's dependencies, clean architecture concepts. In order to write this, I have to separate out the business logic, the repository implementation, from the repository interface, from the repository adapter. One of them knows about the database. One of them knows that it's SQL, but not where it is. The other one only knows that this deals with financial accounts, but doesn't know that it's coming from a database. Right? So we're covering all the seams of the modeling problem. We have three different perspectives that the model has. And then the dependency tests, like Arch test, I'm heavily relying on 𝗵𝗵𝗵𝗺 work here. He has a very good example for architecture tests, where you can, so if you're not a C# developer, you have assemblies and solutions, and assemblies and solutions bundle your code together. And generally, if you're written your code in a clean architecture kind of way, you would create different layers. So in this case, different assemblies for your domain, for your application, for your infrastructure, for perhaps separate teams, separate verticals. The same thing applies if you have a mono repo in Node.js or Turbo repo, and it's all TypeScript, but then you have different entry points, right? So you have different bundles of packages that you create, or different NPM packages that you create, or different React components that you sort of bundle together as this page or component or higher order component or vertical in a clean architecture or a vertical slice architecture kind of way, or screaming architecture at its own, right? Where the top folder says what feature it is, not what layer it is. So these tests help tell you, hey, because we have layers, the dependencies should flow in this direction, right? So the domain should not know about the infrastructure. The infrastructure should know about the interfaces of the domain. So then you can create little games like this where you can say, in a very large team, we need governance. We can't just rely on all the developers doing this by themselves. So new developers who aren't used to working like this will have some kind of test automation that alerts them, hey, you're not allowed to import that package in this side because this side has to be agnostic with all the other vendors. Otherwise, it'll pull in and make the bundle size larger. You've probably seen this a lot, either in very large compiled languages like C# or very large bundled applications like TypeScript, where you deliberately want to do tree shaking or shed some part of the node modules folder and make the compiled bundle smaller. So you might create rules saying, hey, you have a circle dependency here. If this and this happens, you're not allowed to import this one. This one has to be put in a different module so that module A and module B reference a common config module rather than them having circular imports, things like this. So these are the architectural seams that you introduce when you start inverting dependencies, when you start doing hexagonal architecture and you do the silly impl thing, imprint interface thing, user implementation. This is the more typical Java-esque Uncle Bob style of just doing one implementation, one adapter, one use case. But generally, this is the more zoomed out approach to what's going on in the application. And I just got a ping in my ear that Adrian has joined the stage. Adrian, go ahead. I'll just turn off the presentation so you can join. Can I put you on stage? Yeah, he got us a thumbs up. Everybody, give a warm welcome for Mr. Adrian Stenny.
Hello. Can you please repeat what you already said when you just started in detail for me? It was a joke. No, don't.
It was, so we're doing, I have a little presentation on 7 kinds of tests that you might encounter in your legacy application. Right now we're going through the different kinds of tests, and then we're going through a legacy scenario. So right now we're discussing the trio of, if you write developer tests, you will end up having mocks and end up having architectural inversions. So architecture dependency tests help you test whether your dependencies are going the right direction, and contract tests help you keep your mocks have a link to the real world. That's one bit. And usually these contract tests, if you're doing it in a very systematic way, if you're using a framework for what it is you're testing, it's possible that the framework provider, that the framework vendor has contract tests for you. So for example, if you're using React testing library can create mocks for you, but then you can outsource the contract tests to React testing library so that the meta team, or at least the open source community around the RTL, manages whether, does this still make sense in the most modern browsers, which is the main problem jQuery set out to solve. If I write a piece of code, does it work the same way in all browsers? And usually it didn't. And you actually had to, breach this level of abstraction in some browsers and say, well, in this browser, it can't be done. Now we also had this DMA problem with Apple PWAs because we had a standard, and then they said, well, the implementation is slightly different here, but also from now on in the EU, which is another problem. Also, it works, but the API is different. And if you're in the EU, you might not be able to at all. All right, so that's the contract test that you want to test. Because in your isolation, you can...
How would you, just for me, maybe in one sentence, how would you implement a contract test? On which layer of the testing pyramid?
So we're not talking about any pyramids on the stream, because I hate testing pyramids.
I just asked because most people understand what the testing pyramid is. Actually, you need to invert it, but yes.
Import
Raul, I'm a default export. I'm a default export.
Import star.
Please, yeah.
Import Adrian without the curly braces. Okay.
Yeah, please.
No, but it should be import snackable CTO from snackable CTO then, right? It should just be import snackable CTO, and you become the $ in window. You become the jQuery.
I am the $, right?
You are the $.
I'm overwriting every prototype there.
That is great. So where to put your contract tests? So contract tests come in pairs. You have a consuming and a providing side. But because you have a contract, and the contract, if you put yourself in the middle of a contract, for example, if you're a liaison and there's 2 parties. If you put yourself in the middle between them, you're either facing one person or the other, and you have a different contract to each of them, right? So if you have a request response and you put something in the middle, you create 2 problems. not one, right? So this is the nature of contract tests. They have two parts. So generally, you would put them as a precondition in front of the tests, saying, if the contract tests fail, don't run the test pipeline. Because the test pipeline for the developer tests are relying on mocks, and the contract test fails, so I don't know whether the mocks work or not.
Is the contract test what type of test in the traditional technical sense is the contract test most related to?
It is usually a mix of what you would traditionally call an in-process backend test and a backend integration test, right? So it might call the Shopify SDK and download the Open API spec, and then check whether your mocks honor the latest spec.
Schema checks then.
A schema check, yeah. Some people call this a schema test. If you have a more low-level testing quality, let's say, in your contract test, you might just do it as a compilation step, saying, my application is a implementation of that schema. Before we compile, let's download the schema from the web and let's validate it. And you might do this before deploy or after development, before development. It depends on whether you're making changes.
Do you trust into schema versions, or do you say you really think of testing, really testing every, let's say, input output of every REST call?
That's really what you're trying to put down on paper. You're trying to create a test that describes how much do you trust this spec. So for example, with my previous client, we had an integration with 𝗕𝗏𝗃. 𝗕𝗏𝗃 is, I think, a Brazilian-owned e-commerce, like front office aggregator for a lot of B2B e-commerce data. And their Open API spec did not match their API fully. When it came down to like the seventh layer of like a complex JSON file of, tracking a vendor's GPS location, and when I refund a sack of potatoes, the spec didn't touch the spec didn't touch the reality anymore. The API behaved differently because the developers just gave up and said, look, from a certain point, it's just a blob JSON that can be any, and then here's our rules, but we don't know how to express it meaningfully using Swagger. So because we had mocks implemented against the spec, we needed to create a test that says, no, actually, when it comes to these tests, our mocks need to follow what the 𝗕𝗏𝗃 guys said, not what the spec says. And that's what you then have test covered, because then you rely on that contract. You rely on that agreement between, I sent an email to DevRel, to support, and they said, no, this is how it works, even if the documentation is not up to date. Right? And then you keep checking that with every version. So then you would have a consumer on the providing side. Does my mock act like that? And if I make a test request against the real API, does it also continue against the spec? Does it still return that in a situation that I know that it does return that?
Okay, what a contract test in relation to TDD? Just a very, let's say, very open question to you. How would you categorize those both, and how are they basically related? And actually, do you do contract testing in the face of TDD?
I would do contract testing as an platform exercise, not as a feature development exercise. Right. So generally, one of the feature teams would encounter a platform. You would start relying on an API. Ideally, more teams of the company would be relying on that API. So you would be managing that as a platform rather than as, something that you do in process and in a small way. Contract tests are for things like I'm integrating with Shopify GraphQL, and some of their typing systems are not specific enough, right? So some of the GraphQL types return this or that or this, and I have the doc type check it.
Okay.
But it cannot give me explicit answers. But I know that my mock, in order for it to make sense, has to give an explicit answer. right? So you would narrow a type somewhere, and then you would say, no, the mock has to narrow the type. Don't give me that generic answer, because that's not how the API works, even if that's how the GraphQL spec was.
Okay, and who is who is doing that? So I wanted to ask this question before the TDD question, because then it came to my mind that in TDD actually developer is doing that, who is implementing in that moment. But let's imagine a little scenario. So you have a front end aspect in your own application, and you want to display something from an external API. Let's take Shopify as an example. But the implementation with Shopify is done on the backend side in another sub-team of the team. So another developer is doing the implementation, but you expect that on the front end to be displayed correctly as well.
Exactly.
And this is now we have a problem with the API. Shopify made a mistake. How do you actually do that?
So there are two keys to this, right? So just to highlight the 7 types of tests, we have smoke test non-functional simulations on the infrastructure side and on the quick failing side. So these tests don't tell you what's wrong. They just very quickly and reliably, in a non-flaky way, say something's wrong.
The health check, for example, right?
There are health checks. Correct. You're spot on. Then you have the UI integration tests, which is the kind of tests you and I were writing with Cypress, mounting components and then separating out the React stuff from the business logic stuff from the behavior stuff. Then you have the backend integration tests, which are the equivalent of that, but with a third-party API, which you just described. And then we have the developer tests in the middle. These generally test the main core business logic that is a unique value proposition for our company. But because we want them to run fast, we make assumptions. In order to keep them running fast, we make fakes and test doubles and mocks. And then those mocks lose touch with reality. And then we need a contract test or a dependency test to keep both scenes of reality, as a forcing function. Hey, I have like a weird La La Land testing situation here. They run fast because they run in La La Land. But then I need reality checks. And these contract tests are reality checks. So if your front-end team, and now you asked the question of who. Well, the answer is your organization will affect who. If your organization is full stack, which means that every team has a backend developer and a front-end developer, then you probably won't need a contract test, because the deployment happens in one payload, right? So we're following Conway's law here. Also, if you're reading team topologies, this is a stream-aligned team that follows the same route. This kind of team will change the backend in the same deployable artifact as the frontend, so they can deploy it independently, possibly in a backward compatible way with each other, and then you won't have these like weird integration problems. So a team that is full stack wouldn't create a fake front end for the backend team to test, and it wouldn't create a fake backend.
No, they are already integrated in there.
They are already integrated.
We have that a quick intermission. So we have that like the T3 stack, for example, where Theo is a good example for. They say we're bringing front end and back end so close together that you are actually doing full stack again. So the types are the exact same. So this does have other challenges. So you don't have this idea of ports and adapters. You don't have that anymore.
The only problem, and this is a slight of a tangent, the only problem I have with the T3 stack is that you have to share the transliteration ecosystem. So if one team decides to use Babel and some like common JS compatible,
this is what I mean.
The team needs
you don't separate everything anymore, right? It is especially, for example, if you want to build several clients for the same backend, it becomes a problem. So the T3 stack is very good if you know exactly for the next 5 to 10 years what will happen with your architecture. Then this is the better way to go, because you overcome most of the challenges actually, but you have other constraints like TypeScript only on both sides. So you can't choose in that case.
The T3 stack is it's an environment where you can create a domain-rich team, a domain-rich full-stack team that is backend and frontend, and they integrate very rapidly without faking the ecosystem, right? So you can avoid creating mocks. It's a mock-free environment, because everybody everybody is aligned with all of the changes as they're happening, and you might not be relying on a lot of third-party systems other than, let's say, the browser support, right? So you might be like StreamYard is a good example, right? Like they are primarily have contract tests with caniuse.com. Does the browser now freaking support this thing? Is it turned on by default in Chrome version 89, right? So that's what you have contracts against. It's like, I'm assuming that it's turned off. So I have a mock here that says it's turned off. So when I'm running the code, it should by default expect the API to tell me it's off if I didn't ask it for permission. And then when the contract test fails, you know that, oh, Chrome version 94 has turned it on by default, and now I need to change my mocks because my tests will pass, and that is not correct anymore.
Yeah, we have that in a specific series of projects as well, where contract tests are actually the essential tests. So they are by far the most important tests, because all mocks are just, as you said, La La Land. They are important for refactorings and those kind of things.
Very much.
But for, let's say, not getting punched in the face by clients, you need to have the contract test. And this is actually the real test. So if you need to decide you only have one credit and you can only do one type of test, then you need to go as close as possible to the integration side. And this is sometimes a little bit like people don't want to hear that.
And it might separate your team as well. It might separate your team on this side of the integration boundary and that side of the integration
But this is where you, for example, what I like to say is often is that TDD is great for the engineers who implement things, and there is still a place for testing engineers as well. So engineers who are very close to the business domain of the client, who understand every requirement, everything, and is not taking a look how things were implemented, but the inputs and outputs of APIs, ports and adapters, right? So this is what you should look for. So and we have that, for example, if you have another company working on an API which is directly connected with your application, and the API you work with is not a super common standard super thing like the GitHub API or GitHub Actions API, which is very stable, right?
A bug, for example, a bug that PayPal refuses to fix, and then you have some platform team or some staff engineer saying, everybody in our system, in our company is confused by this, so I've test covered it and I've created documentation that, yes, this is indeed how it works. This is an annoying bug to find. And I've spoken to PayPal and they said this is intended, and so many people rely on the bug that they're not going to fix it. So I wrote a test because the documentation is confusing, right? That's a contract test, because you then might have internal mocks against it, so you don't actually have to pay PayPal something for doing tests against.
Little side joke. What is the best starting with T on the T3 stack? Huh? Why is the reason why we should use T3 stack?
I tried to give T3 stack a go. It's catered towards front-end engineers who want backend power. And I'm coming from it from a different perspective. Like I want to be able to control. I would much prefer server-side rendering. I'm more of an HTMX compatible guy, even though I don't like HTMX, the syntax of it. So to me, T3 doesn't really do much.
No, that was another joke. I just wanted to say Tailwind, but okay.
Tailwind.
Tailwind is part of T3, yeah. So you have three T's. I think it's TypeScript, TRPC, and Tailwind.
TRPC and Tailwind, yeah.
That was just a joke, because Tailwind is just for the CSS part.
TRPC is typed gRPC, right? So it's a type-aware remote procedural call protocol where the client and the server have an agreement that it's GraphQL Lite.
It does have impact on tests, so in integration tests, because if for example, if you have a mono repository, you have front and back end in the same repository, same language, same team is working on that, you don't need to write a lot of tests in between both systems, because TypeScript is in that moment already testing or covering most of the things.
The compiler takes over.
Exactly. Exactly. So you can still have problems, and you should have some basic form of testing, because sometimes you can, people who cast too much in TypeScript, for example, run into the problems that this typical as unknown as this, and then you overwrite everything. This is
or
not
memory
good.
allocation problems in C, right? So the compiler doesn't catch it, so you need a test for it, right? So that's the idea.
Exactly. But you can, if you have a typical backend for front-end architecture, this can help you to reduce, because here we are now again at the point where we need to talk about the business side of tests. Testing is about I would say, and I have that quite often with my own things and with other things, it's like you should test what is necessary to test, but not more than that, because test needs to be maintained as well. You need to put time into it. Exactly.
The same way, 𝗏𝗫𝗺 just had a controversial video that you shouldn't write comments. And I agree. Like, comments are not definitive, right? It is possible that you write something in a comment that says, this function has 2 parameters and it's an int and a string. But it's not definitive. But it's not definitive, right? Because the compiler doesn't check against that. The compiler won't tell you whether the comment is wrong or not, which means that now I have to eyeball, do I need to change the comment after I change the comment?
Yeah, so I'm not 100%. So I think it's basically
that's a GSDoc jab, right? So that's the idea of don't write GSDoc. It's generated from your code. Why is it?
I personally like to have comments in particular complex situations when complexity is not avoidable, to give a quick hint, what is this actually about? But if you need too many comments, it's a sign that you have structured your code bad, right? So especially, we all know that extremely long files with extremely, extremely often, or extremely long indentations.
Many responsibilities, the code goes to the right.
And then people tend to, instead of refactoring the code, they start to comment the code.
Comment it, yes.
This is some form of, survival technique, but it's not really refactoring at that moment.
We'll get to that. And then you end up not being able to write developer tests, and then you don't get the power of business logic. You don't get the power of tests that help you maintain high quality business logic. And then you can't answer the problem, do we understand the business problem? You end up going into the problem of, can we separate facts from behavior? And you end up fighting your framework rather than serving your business. And that's the main gist of the story there. We have some few comments here before we move on. Grant says, a test pyramid is where you hide the bodies. Yes, I don't want to talk about the test pyramid. The test pyramid is such bullshit nonsense. Like, it is an oversimplification based on a food pyramid that is just silly. No, let's not do test pyramids. Sanjeev says, in case of test pyramid, God damn it, guys. In case of test pyramid, I think it should be an inside integration test, right?
Now he's wishing that I never joined the stream, right?
For me,
so the stream is about test pyramid now.
No.
Okay, let's read it again properly. Sorry.
No,
in case of a test pyramid, I think it should.
The stream is about waffles.
Okay. I think it should be inside integration tests, right? As for me, contract tests verify and help to make sure integration points are the points at working. Points at working.
So an integration test is a check potentially against production or against the real system. A contract test is a static analysis tool. It checks against the types of the system, the form of the system. So a contract test might go to a SOAP server or go to Shopify. Yes, I know. I had the same. I felt that.
Why do you say so? Don't say those words, please.
And download the XML and validate the schema against your definition. The schema definition against your implementation. Or it goes to Shopify and it downloads the GraphQL manifest and it validates it against your client. The same thing as you would do with Protobuf or gRPC. Whereas an integration test is actually querying the server and checking how it behaves. Or querying a server in test mode, but it is maintained by the vendor. right? So that's the difference between integration test and contract test. Contract test tests the shape, the type, the schema, and the integration test tests the actual some kind of live system, even if it's in staged mode. You can have the same thing with databases, right? I can test against the contract of the tables having been created in an SQL database versus the actual correct data being there in the production server, right? So that's the difference. Raul, should we use contract test just for external API SDK and service, or also for another microservices modules that are not part of our module microservices? No, none of the two. You only use contract tests against mocks that you have created. Right, so you have a contract test for every mock that you have created for your developers.
Why? Explain the why. Not.
Well, because the backend developers will create a simplified version of the backend for the frontend developers, so that they can maybe, I have version 1 and I'm about to create version 1.2, and version 1 works, and for version 1.2 I will create a mock, so that the frontend developers can already integrate while I'm spinning up the system. Because they can't stage it anywhere, because it's not really written yet, right? So
Typical Postman backends.
Typical Postman, yeah, and Postman is a good contract test framework, right? I'm not saying it has to be in code. You can do it in a Postman collection, and then exchange cloud-based Postman orchestration, or you can have Postman in your CI/CD pipeline. This is then generally a team concern. Somebody on the team will do it, possibly even on the planning stage or in the TDD stage. But generally, it's a more collaborative effort. You might even do it as a sprint 0 or something equivalent in Scrum, where the front-end people, where the two boundaries, the two teams or the two sub-teams will get together, agree on a contract, create mocks for it, and then export it to Postman. And then they will go their separate ways and start integrating against the mocks. And then they will check whether the mocks still work together by creating contract tests. And then they will create integration tests if necessary. That's the idea. But the contract tests are testing your mocks that you have created for somebody in your company that is outside your team, right? So that for somebody who is outside your delivery cadence, I deploy backend when backend team is ready, front-end team deploys when front-end team is ready. Or maybe it's the other way around. Maybe I have a account management team and it's full stack, and I have a Spotify player team that's also full stack. So I'm not mocking my side, but the two of us together might be consuming a mutual authentication service, and I'm using a mock of it because I don't want to actually cryptographically sign all of my test API calls that I'm doing internally for my integration tests. So you would mock the middleware that handles authentication. Raul also has a comment on comments. Comments should clarify why we made a decision, not what, or explain what the code does. Exactly. You have AI for that now, right? So you can just highlight a piece of code and have the AI explain it to you. Stop documenting this. Stop putting nonsense code in your code base, because an AI can just give it to you on the fly, just in time. So I have an example for contract tests. I see we have a lot of questions on that, and that doesn't surprise me. So contract tests.
So many dollars.
Yeah.
Is it how much value or how much they cost?
How expensive they are. They are. Yeah. How expensive they are to write, how expensive they are to maintain relative to the code base. Right. So generally 50% of your time should be spent test writing, and 50% of your time should be spent like feature writing. If you're doing TDD, if you're doing implementation. So a lot of teams generally have this problem of, if we do 100% implementation and 0% test, there will come a time when we'll have to do 0% feature and 100% test. That's the general story for most dysfunctional, low-quality teams. This is an example.
I would even say in a more negative way. So you start to refactor and change things ground up, which costs more than you actually would have implemented.
And the longer you wait, the more
you want to leave the company.
Yeah, that's on the slide as well. Right, so this is an example of a contract test using Pact. So specifically Pact on TypeScript using Jest. So Pact is a contract testing framework. It's, I think, Pact.io, Pact.io, yeah. It's a contract testing company that specializes on microservice technologies. And basically they help you write the the duality of contract testing, the consumer side and the provider side, right? So the person who defined the schema of the mock and the person who expects to consume the mock. So you generally create, rather than integrating against a real Shopify SDK, you create a fake of it that speaks some part a little bit closer to your own domain language. So it doesn't have the actual, you don't have to have the correct GraphQL word for word, but you can express it in your domain's language of, okay, give me the top 3 orders from user A, right? So you can write the mock from that perspective, but then the underlying system is following a contract. Then you would have a test whether you're honoring that contract. So for example, in this code example, the gist is this URL. This URL is spun up in a Docker container. The Docker container is third-party code. And then we say, there's dragons in here. This is something I don't own, but I expected that when I send it this, I expect to get this back. Right?
And
so
this is called dragons.
No, but the idea is that I am writing silly code because I am testing my assumptions, right? So I am testing my assumptions of what the agreed on schema for writing the mock interface was, because the interface was given to me by some module that I installed, by an SDK that I rely upon, or by a third-party service that I have received a Swagger API spec for, or Open API spec for, or maybe an event schema definition. Another example that I have here is similar, that it says, when I'm talking against a very specific path, I want that path to act this way, and the URL is structured this way. And when I ask it X, it gives me A. When I ask it Y, it gives me B. And you have a mock that does that. But here you actually have something running expectations against a real server or something similar to it. And then you check, okay, if this test fails, it's a signal to me that I need to fix my mock. And all of the tests that rely on this mock now give me false positives. That's the point. Right? So you have full observability about the reliability of your test suite. So you don't have this stuck in la-la land loop of, yeah, tests fail, but I don't want to deploy because, the tests are la-la land. So that's contract tests. Now let's move on.
To explain the La La Land principle. So I think this is important to understand for everyone who is doing software right now. It is like La La Land tests are not bad. La La Land tests are just for another purpose. You should not purpose or should not use unit tests to actually try to test any form of integration of contracts.
Yeah.
So unit tests where you have this La La Land problem are actually just for themselves and their refactoring. Oftentimes,
very, very low locality, so you can write code quickly, and you can answer the question, do I understand the business problem? And as my understanding of the business problem grows, can I reliably and quickly refactor the code that deals with business?
Exactly.
That's the point of developer tests. And unit tests are a subset of those, right? So all the tests that are running all the time live as I'm writing code that are not integration specific. But because they are fast, because they're isolated, they also don't have a touch with the production system reality, which means that we need to manage that uncertainty. So, well, otherwise we lose confidence in our test. Otherwise we might have a test suite that's all green, but I have no confidence that it works in production. That's the worst kind of test suite. Okay, we're going clockwise. Next thing, backend integration tests. I think I left this one last because everybody knows this. This is the typical thing that Raul is asking about. This is the typical thing Sanjeev is asking about.
What is Raul asking again? We need to take a look.
Yeah, Raul asked earlier.
We have so many comments. We should go through them.
Raul mentioned, should we use contract tests for external API SDK services? So that's basically the answer to this. I've already addressed this. And Sanjeev I meant, for example, in context of distributed systems or microservices, contract tests help to verify those integration points. Yes, but only if the services are being maintained by different teams. If one team is maintaining 10 different microservices and it's a cohesive unit, right? So it makes up a private mesh that from the outside appears as one gateway, as one
Yeah,
federated
it's typically
container.
API gateway, those modern
You
ways
shouldn't
of
have
doing.
contract tests for that. You should just integration test all of that because you own everything, right? So the point with contract test is that there's a piece of the code, there's a piece of the puzzle that you don't own. Now, I'm not saying ownership in that you need to be the alpha and you need to decide who decides and when to deploy and what decisions to make. Not ivory tower architect style of ownership, but ownership in the sense of is there a team involved with this that has their own set of priorities independent from ours? That's generally when you have contract tests.
Yeah, so I would
So they
like
can
to
deploy
describe it with a
independently.
very easy example. We have done the 99 bottles cutter. And in there was, I don't know, I think it was 97 lines, which were basically the same, just with an iteration of a number in it.
96.
And you don't...
There are
96.
4
and-
exceptions. Yeah, there are
Exactly,
4
and
exceptions.
you don't need to test every of those lines because you own the implementation and you know that there is an iteration going on.
Right.
So you don't need to test the physics of JavaScript; it will work. So
Yeah, you
you
don't
can.
need to test that a for loop produces an array of things, right? Like that is inherent in the like you don't need to test that an SQL database is an SQL database.
Exactly.
Right? Like that's silly. If I send this query to the SQL database, I know that there is flakiness in it. There is a non-determinism to how the query planner works, depending on what's inside a database, how large is the index, how large is the table, how is the table partitioned, is it neo-SQL, is it cloud-based, is it on a fixed machine with a fixed size? There is flakiness to it, right? But you shouldn't test that an SQL database is an SQL database. You should test your assumptions about how should this behavior be expressed.
Yeah.
We saw a lot about this in the Go API TD example kata that we did with Jonathan Hall 2 weeks ago on Monday. You can check it out on his YouTube channel, Boldly Go, and we'll have him on as a guest as soon as possible when we sync up.
Wasn't
schedules.
there a planned guest for this week? No.
Yes, but he has anniversary scheduling issues. Yes, but we keep bumping into small roadblocks. So the point with backend integration tests is that these are generally the things that help you have full confidence that some integration aspect works in production, that it will work in production. My business logic that I've isolated from integration tests works, and I've also done all of the negation side, right? So I've isolated the domain, and then there's an integration problem that is not tested. And if we test everything up until the boundary, and if then we developer test everything on the other side of the boundary, then we have maybe not 100% confidence that it works all the time, because we don't control the third-party service, but at least we have full confidence that we have predicted as much as can be predicted. We have done our best to make sure that if we deploy, we maintain a consistent high confidence that everything works. Even if the uptime of the system is, 99.5%. If the desired uptime of the system is 99.5%, and we can have downtime because of PayPal or because of Stripe or etc., we shouldn't pretend in the test that it has to be 100%. We should just do our best to make sure that we are doing our best when it comes to the quality of the test, the relevance of the tests, and to the definitive nature of the tests. When a test says it's doing something, it should do something. And when it fails, it should tell you what's wrong. Right? For example, smoke tests don't do that. Smoke tests tell you something doesn't work, but it doesn't tell you what. Right? Whereas with backend integration tests and with developer tests, you don't want them to randomly fail. You want them to fail saying, this doesn't work. And you only want them to fail when this doesn't work. Database didn't spawn up because there's a hard drive limit. You don't want the test to run. You don't want the test to fail. You only want it to fail if it runs, and it fails for exactly only this one reason. Right? So this is, again, we can have another topic about how to write tests. Like tests should only have one expectations and have one assertion. We showed a pretty good example of this last week on the Thursday stream when we were refactoring your Storyfy project. So viewers, if you're interested, check out last week's episode, and I even have a code snippet of it. Okay, we have some comments. I have an example of backend integration tests from that episode. So it's basically this. It's basically what you and I did no, that's the front-end integration. Sorry. Backend integration test is very similar. You say there's a database here. Database will have a certain schema. I have an ORM. It has certain data. When the schema is present, when the object is present, when the ORM is built, if I then describe a repository like this and I do a request against my API, I expect it to return this. Right? But I don't want the test to run if any of those setup steps failed. But when they pass, I want to have an endpoint that says if it integrates correctly against the database, then it will return this.
Does this still count as one expectation, or does this count as 3 expectations?
This is a language problem. It's hard to express. So what
You could express it as a schema.
Yeah, you can have expect book to match object equals.
Or just a schema check.
Yeah, I think the problem is in the this one can be checked. This one can be checked easily. It depends. If the ID is a value object, because it says expect book ID to be, not to equal, right? So if you're doing identity checks, then to match object might not. But if you're using just a lot, to match object can replace those 3 expectations with 1 expectation, right? So we're just testing, does it match this JSON basically?
Would you implement something like YAP and use a synchronous schema check and the Boolean as a to be true thing?
Maybe, but that's more sugar. I would take these, for example, particularly in this example, I would take these 3 lines, hit extract, and I would extract a helper that says book matches schema, right? So, but if you have Zod or Yap, then you already have that, and then I would just yoink in the helper and validate against it.
Well, I don't like to create helpers which you only use one time. This is
if it happens more than once,
especially in tests, they're not reusable really, because you don't want to reuse in a test too much, because then you have bad tests again, right?
And so the benefits of backend integration tests is that they provide a high trust form of realism. You know that it's an integration test works, your system works. If your unit tests honor the contract towards the integration test, if you are mocking it, right? So that's the reality check. That's how you get the checks and balances all the way down to the unit tests. The drawback is that every integration point causes your test to be flaky. I have a database. Well, if the database is out of memory, the test won't run, and I don't know. Will it crash? Will it cause an error? Will it fail?
You don't. This is one of those points why integration tests.
I can have a Docker image in the CI/CD pipeline. Somebody can pull the Docker image accidentally.
You should consider. This is what I would really recommend, to not put an end-to-end test as a requirement for your pipeline. You can have it as an asynchronous thing, which gives you feedback after the deployment.
I would always run end-to-end tests as smoke tests against actual production.
Yeah.
So that you know that it's actually running, so that you eliminate most of the infrastructure concerns.
Yeah.
That's a very good point. And then the other side, the UI integration tests. This is code that you and I wrote. So this is an example, right, where I say it's an integration test because I am mounting a component. The component is using some state management library, but then I'm asserting that what I care about is that this is the domain concern, right? So I care that there's a map box, and I want the map box to be in a certain mode. And here I say, when I mount it this way, the way I mounted it, this was my input, I wanted to spawn on coordinate 0 and 0 by default, because that is agreed upon for my business domain contract. Right? So that is, but this is actually mounting it. This is actually in a browser. The browser actually has a GPS, right? So this is already integrating against a complex system, and we're not mocking any of the units, even though we might exert control over.
I disagree. This wasn't an integration test because we stopped the geolocation to 0, 0 in order to run that test.
I disagree with that because we stopped the geolocation unnecessarily. Because the real point here was that we have separated the design system from the behavior, and we created proof that we can mount the component and exert influence on its behavior. The fact that we had to mock the GPS system, you already had in place, but I think in this case it was unnecessary because Cypress is capable of mocking the GPS system in a way that we wouldn't have to. We can control it at a much higher level, at the machine layer or at the orchestration layer, or just in my browser layer, but by virtue that Cypress just runs in a browser that we can control and see. But if we run it in a headless mode, then we might exert control over it. But in this case, we would also then need a contract test to check whether our action for Cypress that mocks the GPS is actually mocking it correctly. Does the web API for location actually honor this kind of type, this kind of structure of data, etc., etc., etc.? So that makes this an integration test, because even though
but this wasn't this test what you're talking about. This test was the standard should be 0, 0 when you open the component.
No, this test is running inside the sandbox where the mock for the GPS is available. But particularly for this test, it is coincidental. We're not testing that behavior. That would make it a developer test if we weren't mounting it. But because we are mounting it, right, there are two axes to UI integration tests. One is that you are integrating correctly design system and behavior. The other one is that we are separating from the UI framework. Even though we're mocking the GPS, we're still struggling with the coupling between framework, state management framework, and HTML, and whatever is managing our DOM. So that still makes it an integration test, even if we mocked some little bit of it. But we are testing the parts that we didn't mock, right? So we are always testing that which is not mocked, which is why a lot of developers get stuck over mocking in unit tests, and then they actually end up not testing anything. That's a common problem. But that's a common problem when there's such a coupling hell. There are circular dependencies, and then you create mocks for your mocks, and commonly junior developers fall into that trap, and people just tell you, just stop mocking. Like, you're over mocking, you're not actually testing real code, you're just testing against your understanding of your mock, which is a smoke test. And
I wouldn't blame juniors here. I think this is a common problem for everyone who's not taking putting enough time into thinking about things before doing that.
Yeah, when I did prep, like research for this talk, I found that unit tests you can Google, but it's already difficult to say what is a unit, what is not a unit. Everything else, smoke tests, integration tests, there is no material on this. In 2024, on the internet, you ask ChatGPT, it gives you nonsense. You check the web, everybody has a test pyramids, but nobody can explain to you exactly what is an integration test, exactly what is a smoke test, exactly how does integration make sense from a backend perspective, from a React perspective. What does integration mean for T3 RPC? What does integration mean when my team is shaped like this? What does integration mean when my team is shaped like this? So that's why we're having this session today. What did we not cover? I think it's worth checking the developer tests, because that's kind of the main point. Oh, the smoke tests we haven't covered. So smoke tests are generally what you would consider health checks. Right? So this is a health check that says, hey, open it up, log in, and check if I can see this. And you and I wrote one as well last week. And this is a smoke test using Postman, right? So you create a Postman collection. It says, when I go here, I check this. If this passes, I'm going to run the remaining tests. If this doesn't pass, I have 100% signal, a reliable signal that this artifact is definitely not a release candidate. Like, we are definitely not releasing this if the smoke test fails, even before the entire pipeline has run. That's what a smoke test is.
In orchestration, you have the typical health check parameter where you can give a route, and if the route doesn't give you something like code 200 or some live sign or telnet or something like that, then basically it's red and the test failed, and you need to investigate what actually happened. Sometimes those tests give you some kind of JSON, which, for example, the database is not available or something like that right now. Then you have a little bit more, but you still need to investigate. But those are smoke tests. And I think they are the most common tests we have, because you actually need to have that in order to host your stuff. I see them more often in software companies than actual software tests, right? But they are, let's say, they are very, very on the surface. So they don't tell you anything really detailed what's going wrong. It's just telling you that something is severely not good. So they don't even tell you about bugs. They just tell you that something really, let's say, it is simply not working. It's something between, it's basically a binary test. So it is something like, 0 or 100, right?
Yeah,
exactly. Yeah.
That should be binary. Yeah. Here's an example of the GPS that you mentioned earlier, right? So we say we're testing that we're rendering something when the API call succeeds, and we mock the API call because we don't care about how the API call happens. What we care about is how this code behave when
a certain thing is happening.
When a certain thing happens. So this we might have a contract test for the mock, but we are still integrating. This is still an integration test. Why is it an integration test? Because we're integrating with this render behavior, we're integrating with screen, we are integrating with behavior about what does it mean to have text, what does it mean to text to be in a document, and what does it mean to query something on the screen. We're still integrating against all these concerns, and it is that the component's behavior to put that on the screen that we're testing for integration. What we're not testing is how the API made its call and what the network protocol needs to be, and is the server online?
But there are actually two definitions I know, and I think I'm not sure if they are polarizing or not. But we have that people say, what is a unit? So you can think of a unit in a traditional way as a function or a method of a class, for example, and you want to test that. Some say, okay, a class is a unit. Then the other ones say a component is a unit. But the component can consist of multiple other things, as you just mentioned.
Multiple dimensions, yeah.
Right. So is the unit the molecule, the organism, or the atom? What is it exactly?
It doesn't matter. It doesn't matter. You can have a class, you can have a function, you can have an entire use case.
And this is the point
what matters is I call them developer tests because with developer tests, it's very easy for me to tell you developer tests are those tests that the developer runs constantly while writing code.
This is very good.
I don't care what a unit is. I don't care what a unit is. What I care about is that if it ends up spinning a database, even that I don't care about. It can still be a non-unit developer test if spinning up the database and then destroying it takes 4 milliseconds. If it's that fast, all the power to you.
Yeah, there's actually a good example
scale.
Which adds to what you just said. 2 years ago, we developed a lot with IndexedDB against PWAs. And this was about the file system stuff I already talked about. And everyone is considering something like local storage or IndexedDB as given. It's simply something which is physically always working. And it's not. On Apple, it's simply not. So especially if you have, for example, if the database is full, maybe it's broken because you have a
permission, you remove the SIM card, it limits your permission scope.
Exactly.
You log out of your Apple ID, it limits your size, right? So everything.
Then you need to have tests covering those things. How is your application actually handling those things, or the quality of resilience in this case? So is your app still working and providing some form of user feedback, or is it crashing? This is, of course, an integration test as well.
Yes. I mean, it can be very fast. It can still be a developer test if you manage to spin up the fix in such a way that you've actually managed to create what you would consider reliable mocks using Docker. No problem. But then you have to contract test those. And if you don't want to do that, you create integration tests and you don't run them immediately not on every keystroke, but maybe before commit. But
we have 6. Shall we go through comments?
Yeah, let's go through comments, but then I also want to go to the workflow. So the code example we had, so the integration tests we looked at, where were we before? I wanted to show something real quick.
Smoke test.
I think we showed the smoke test. These are health checks. One is with Codeception, one is with Postman. Dependency tests are using ArchUnit from Milan. I recommend you check out his channel. The contract test, I recommend Pact. Somebody also in chat recommended Pact. Philip, for mono or turbo repo contract tests become easier as a contract can be shared between the team within the same code base. Exactly, it's the same language, it's compiled the same way. You don't have these like I compiled it, but it's an older version of C# or .NET, or it's Java 6 and my side is Java 7, right? So it dodges bullet on that aspect.
What I see, I want to add something. For example, when we take a look at JavaScript backend development, we have the framework Nest.js out there as the most prominent one, next to Express, which is more like a library for me. But let's take the Nest framework. When you take a look at the Nest framework and you want to build something like services, even microservices, they offer you to actually have one code base and abstract many services from that code base, which is an extreme form of what we just said. So we can argue about if this is now microservice or not, but they call it microservice in their documentation. And you have actually only one code base, one dependency, basically set of dependencies, but you create multiple functionalities out of the services as you assemble them.
I would always be hesitant calling it microservices. A key ingredient you need for microservices is several teams, right? Like you can't have a solo team microservice because the only thing you can build is a monolith. Like, so what you care about is that when there's a second team, they are building their own monolith. So if your team is building your monolith and their team is building their monolith, those two small monoliths make up microservices. That's the whole point. If you end up building your own services, but you're still integrating against the same database, you're building a distributed monolith, not microservices. And usually T3 stack, even Nest.js, it does smell more like a distributed monolith.
It is.
Less so than microservices.
What I wanted to say by that is not what a microservice is. This is the reason why I started with services. So we have, especially in the cloud native terminology, this idea of services, and all people always say microservices. The point is that there is a difference between those two in particular, because we want to be precise. If we describe it to another professional, we want to be precise in those things and not just using the terms microservice because I have a specific service in a Docker which I deploy, but it is basically, you can't really deploy the others without updating everything else as well. So the tendency is, while we're going through that distributed thing, which is actually wrong as well, because this is, the point is monolith is actually one application, and the distributed monolith is some kind of fake word for something in between both worlds. And the point is,
it's about orthogonality, right? So I say, well, the code is independently deployable, but the common infrastructure is not, like a database schema, right? So it ends up splitting the code base in that, here's the code. But the code doesn't manage the database. The database has its own version system with some.
The problem is the more time you have, the longer the discussion becomes. What is then the unit where you talk about still a distributed monolith? For example, micro frontends are the very same thing, and you say, you have micro frontends. Take a look at the inspiration part of a shop, the payment part. But if you take one away, it's still not working. And then it's still a monolith. It's still one application. There is still cohesion.
It still has to integrate.
Exactly.
But so the question is, can it independently deploy? If you have to deploy it all in one go, then it's not.
Exactly. So I think to reduce it a little bit to a practical sense for people.
Micro frontends is when I deploy a website, and then when I pay with PayPal, it opens up an iframe, and there's whatever PayPal deploys today, it renders. Right, and an iframe is a crude way of dealing with that. A richer way of dealing with that is when you do, I will download JavaScript for a component, and then I will render that component under my domain so that it has full control over the security space of my browser window, which might be a huge security risk, which is why then you have to make sure that you trust the way you orchestrate your micro frontend components. Here's also an example. One of the common things that happens when you start introducing indirection in your code on your integration points for your developer tests, especially if you go from this declarative, imperative style to more functional style of programming, you might end up adopting the collector pattern, which you might also know as event sourcing or event-driven architectures, where in order to make your functions side effect free, you will give a function a bus or an event queue of some kind, and then you will run the function, and then you will inspect the event queue afterwards rather than looking for the return value or whatever it is. And then you can also abstract away this integration scheme of, well, in the actual system on production, it will actually go and use protobuf, which Philip mentions, or it will check gRPC or AMQP on Rabbit, and then it will do something and put something back, put something else back, possibly in another, right? So this is the event processing. Then you say, expect the event to be in the queue after I run that command to be this, right? So that's an example of indirection that usually happens in larger, but it has that sort of nuance of it smells like enterprise integration software. But hey, the other Philip mentions for mono or turbo repo contract tests become easier as the contract can be shared between the team within the same code base. So this is the T3 stack discussion that we had. And packed IO. Yeah, I recommend packed IO for non-mono repo when you end up having to export some kind of XML or some kind of JSON, and then you actually have like a Kubernetes cluster or a Docker swarm, and then each bundle of clusters or each cluster has its own mocks that it provides for other developers, and then you can basically contract on the consumer side against that, so that you can create mocks if you need them, or maybe they already supplied mocks for you, and then they verify the providing side during, let's say, a nightly run rather than in the developer phase. Sanjeev mentions, by focusing on the contracts, these tests make sure that the integration points between services work as effectively without having to perform expensive end-to-end tests that might involve the UI and the complete execution path from front to back. Yeah, so the problem with end-to-end tests is that they are closer to smoke tests. They tell you something's wrong, but you don't know. Like, is the problem UI specific? Is the problem middleware specific? Is the problem that we run on this space somewhere? Is the problem that I'm on the wrong domain name? You know, did my SSL certificate expire and I'm doing SSL determination incorrectly? So the end-to-end test generally won't tell you what's wrong. It acts like a smoke test, which is why I didn't put end-to-end tests onto this, because it's nonsense. And they're super expensive. The relative cost to you writing an end-to-end test is huge compared to the time it takes for you to write the actual code it is testing. That's why we call them expensive. You wanted to comment something? I'm speeding ahead because I had a part of a presentation. I just want to rush over.
Yeah, no, I don't think that end-to-end tests are nonsense. This is not what I think. I think the problem with end-to-end tests is that they are often misused.
Yes.
Misused because the problem with end-to-end tests is you can go very deep into detail, which you shouldn't. So you can misuse an end-to-end test to actually test the unit.
Yeah, I mentioned this early on when you were not present. I can take any of these 7 tests. I can take any of these 7 tests, enrich them, give them detail, give them more knowledge about a system, and they become an end-to-end test. They become an end-to-end test that's testing integration. They become an end-to-end test that's smoke. They become an end-to-end test that takes that flaky simulation thing, non-functional thing. They become an end-to-end test that tests some kind of contract and a unit test at the same time. But it becomes really clumsy and really expensive because it has too much detail. It is coupled to too many things. So when it fails, you don't know why, right? So what you want from a good high-quality test is that it should only fail for one reason, so that when it fails, you know why it's failing and where you need to go.
But this is when you write new systems. If you have very old legacy systems, you always end up with some form of end-to-end test.
Legacy systems, you say? Well, I'm glad you asked, Adrian, because look, I have a flowchart.
Oh, yeah.
Look,
this is why
you're here probably, and I see we still have 30 plus people here. So let's play a game. Let's say here's Dennis's flowchart for dealing with legacy systems and coaching and everything involved. Before we go in, Ludwig's comment: would schema validation with Postman not be sufficient for our contract test? It looks like Pact has more capabilities. Yes, it would. If the thing you are testing with the contract can be detected in the schema. So if I'm telling you, my top notifications have to return 3 items, and the second one has to be a friend request. It's possible you can't define that in the schema. It's possible the schema is written with a spec that cannot be that particular, right? So it's this question of, can you define tuples, and can you define a schema that says the second element of the array is always this subtype? If you can't, then it's not good enough, then you need packed. If you can, then the schema check is sufficient. You've probably seen this in TypeScript as well, where there are types that you just can't explain. You know, an array of numbers is different than an array of 3 numbers, and it's different than an array of 3 numbers where the middle number is always 0, right? So I can say I have an array of numbers, 0 and then number. It's a different type than number array, right? So if your Postman or schema check can be that specific and you don't have this problem, sure, use it. But if you have this particularity of, you know, the first element is special, or the last element is special, or every 10 elements there's an add. I have search results, every third element is an add. You know, can you express that with schema? If not, then you need code. Then you need packed. Great question, by the way, Kyle. Okay, Sanjeev said, thanks for the stream. Distributed monolith questions. Yes, and Sanjeev says, and of course, makes sense in case of different teams. Yeah, so the microservices are about different teams. It's about, can different teams move independently, which means that everything they own is independent, including the database, including the infrastructure. Possibly the only thing they share might be some part of the type of the CI/CD pipeline, maybe not even the unique setup of it. Okay, legacy bingo.
Oh,
You are in a company. This is how I would generally go through an audit about a company that has legacy systems. So legacy system being, it's, you want to make changes to it, it's hard to make changes to it, it's not test covered, and for some reason it's very valuable to the company. Are the authors still on the team? So the authors of the original system that is not test covered. If they are, let's go here. Can they describe core functionality to you in plain English, right? So we're adopting this BDD mindset of, can you write English text that describes, without technical jargon, what the system's behavior is, not how it's implemented, what the behavior is. When a policyholder goes to this page, they can sign up for one policy. You know, that's a good behavior. It's not a user logs in, user clicks this. If they don't have an X object attached to their account, they can click this button to create a new request. That's not plain English, right? So plain English. If they can't describe what the system does in plain English and they are present and you also don't understand what's going on, there's only one solution. You got to pair program with them or the product experts until you figure out what the fuck the system is about, right? Because you can't write any tests until you can express, do we understand the business problem? There's nothing practical you can do if you don't understand the business problem. If you've adopted code that was created by code monkeys, by developers who were just said, write this code, please, write this code, please. You see what ChatGPT produces. If that's how you treat your development team, your engineering team, then that's exactly the quality of the code that they produced. And it's going to be very hard to test because nobody can separate out the seams of implementation from the seams of behavior.
Oh, if you said that okay from the beginning, you reached high quality.
Yeah. Exactly. Now there's another case. Maybe the authors are not with the team anymore. Usually when I coach teams, it's scale-ups. Code base is 5 years old, 6 years old. Original team has left the company. Do you know how it works? So obviously it works. The business is in business for some reason. So some of the time, for some of the users, the functionality works. But do you know how? Do you know why it works? Do you know what would make it stop working? Right? Like that's the point. If you know, same question. Can you describe it in plain English? If yes, then since it is working right now, cover what's working with smoke tests. So that you then use those tests for TDD. You use the tests for the smoke tests for TDD so that you are immediately triggered when you make a mistake. right? Because you are now in a position where you say it works, and I can kind of describe why it works, test against that immediately, and do this outside in legacy TDD cycle, where you start with smoke tests and you keep suffocating the problem with smoke tests until you know that if you make a really bad mistake, the smoke test will immediately alert you. It won't tell you what the problem is, but because you're making such small tests, you can tell, okay, these 3 diffs were the problem, these 3 commits were the problem, and then you can slowly build up the confidence to start refactoring the system. This bingo, is this something you created for the stream, or is it something you're using in your coaching? Both. So this is the first time I've written it down.
He's using
in my coaching. This is the first time I've written it down, but I use this all the time in my coaching sessions. So if you don't know how it works, then same problem as if you didn't know how to describe it. You need to now go talk to your stakeholders. If you don't know how it works, do you want to, now or in the future, make changes to the system? Because if you don't know how it works and you're never going to change it, leave it the fuck alone. Because it works, you just don't know why. If you never have to change it, leave it alone. Now, the problem is software degrades as it ages. Frameworks have to be updated. Libraries have to be updated. This is just a temporary solution. So if you have to make changes to the system, now the question becomes, can you separate the new changes you're going to make from the old changes? If you can separate the new changes from the old changes, start with dev tests. It's very easy to teach people how to write dev tests, especially unit tests which are isolated.
But this is already a migration. This is not development.
This is already a migration, but this is coming from a perspective of the legacy part of the system works. We want to do something a little bit more brownfield. It's usually an enterprise that wants to do
it's
a
a
little
Strangler-Fig pattern. I know.
It's Strangler-Fig. It's typical Strangler-Fig. Yes, well articulated, Adrian. Yeah, this is typical Strangler-Fig. I don't know how it works. I'm suffocating it. But the new code I'm going around, I will integrate, right? So I will integrate against the old system rather than writing code inside it. I will create something like another monolith next to it or microservices. And then everything that's new, we aggressively test cover and we keep quality high. And over time, we extract functionality from the old system because we don't understand how it works. And by extracting it and rewriting it, we will get the knowledge. And hopefully, as the business says, oh, the old part of the system, this part can be shut down, this part can be shut down, this part can be shut down and replaced with this. The replacement you test cover, and then gradually by osmosis, you will create a culture of quality. But this is very painful, and this requires a lot of discipline. Now, if you're not so lucky that you're making changes to the old system and you don't know how it works. The problem is, well, if you're not making changes to the old system, now the question is, will you at some point be forced to make changes to it, right? So are you just maintaining it? Now the question becomes, if you're just maintaining it, is it independently just a front-end project or just a back-end project? Or both, right? So is it a full stack system that you now have to maintain? You will never add behavior to it, right? So that's what it means, changing as in add behavior to it. Now you just make sure that it's up to date on security and the framework is sort of not end of life, right? So you're just doing the bare minimum skeleton crew, keeping the lights on. This is really annoying. This is really annoying to do. If it's a specialized project, so just backend or just frontend, do you know how to separate dependencies? Right? So do you know how to independently upgrade one package without making a mess? If you know, then cover the critical journeys with integration tests, because that's easy, right? You cover if you're about to update a package, cover that with integration tests, because that at least after you update the package, it might be that the newer version has an SDK, which will be a lot more friendlier to testing. So you get a little bit of a bump in quality for free after migration. And then you just cover that. The problem becomes, if you don't know how to separate dependencies. If this to you is just a giant ball of mud and it doesn't make sense, and you can't make sense of the peer dependencies from the dev dependencies, from the actual dependencies, you have no idea how it compiles, it does some weird compiler magic in the background, then now you sort of need to look at it more from a systems perspective. Do you even know where the boundaries of the system are? Do you know where it stops? Like, do you know what kind of functionality it has and how it overlaps? If you know, then you can cover parts of the functionalities with dependency and contract tests, right? So you can write contract tests, like arch tests, where it say, okay, so this part of the system should never include a module from that part of the system. So you can start documenting it. If you're using something like 𝐓𝐞𝐡, this is
Exactly.
very...
I just wanted to mention that.
This is very practical because 𝐓𝐶 can give you this for free because it basically does GitHub forensics. It goes to your GitHub history and checks what the change frequencies are. Oh, every time you change this file, you also changed that file. And the author was always the same, and that author has now left the company. So that there was this cross-boundary coupling here, which isn't obvious from the architecture, and the person who owned that coupling, who understood why that happened, has left the company, right? So you lost that knowledge. So then you can clamp that down and say, okay, this obviously belongs together because its original author thought they have to change together. So now let's define that. Let's define whenever we need to move this into that folder, or we need to move this into that package, or we need to, when we deploy this, we always need to deploy this, or these two can import packages or classes from each other, but not from outside. And then you can write tests for that. You can not per se tests, but like a config of validation. You know, that's usually what these dependency checks are. It's like you're not allowed to import from that. You might have a linter for your package JSON, less so than a test. But now you're really grasping for straws here, right? This is really annoying to do. And you're just setting up guardrails to make sure that you really don't make a mess in a system you don't understand, you haven't built, and you're just trying to maintain. So you're really just setting a guardrail of, I do not want this critical system to fail because we don't know how to debug it. So we're just really setting it up, building confidence, slow and consistently over a very long time horizon, years, possibly a decade. In banks, it's several decades. This happens all the time in banks.
Another little thing which is often important to understand, when you do legacy migrations, it's very often the case that you, especially because of security reasons, you start to hide your old system behind some form of gateway, which means that this aspect of that you don't need to upgrade your software anymore. Sorry, actually, you need to upgrade your software because of security reasons is often mitigated by something, for example, like Nginx WAF or something like that, or other services.
You adopt like a least trust security protocol, and then if you have a system that you don't trust, you just hide it you hide it under another layer that you trust even less, so that you know that if somebody breaches this, at least they know how to breach two things rather than one thing. So you significantly decrease, this is basically two-factor authentication. I know your password is stupid. As much as I tell you how to do good passwords, just if you do two-password authentication, I don't need to trust that you know how to make good passwords, right? So I can get power law curve gains on your security by adding another component and gating it harder rather than teaching you how to fix the underlying problem. That's usually what you're doing here. And that's a very good analogy. Thank you. Then if you don't know how to split responsibilities, and this is a large project that you don't know how it works, and you don't know how to define the boundaries, now you really need to consider help, outside help, right? So if your tech and business leads are giving you enough time and autonomy to manage this problem, that's the best time to get a technical coach on, right? So you can reach out to me or Adrian, right? So that's my publication, and this is Adrian, and our tech journey, this is what you're watching right now. If you want help on how to manage this situation, it's a great start. If you want to take the next generation of developers in your organization seriously. Because face it, you are here because some part of the legacy system is valuable. It produces revenue, and you don't want that to stop. In fact, you want it to increase over time as you scale the business, which means that if you want to take this approach to a higher quality level, the big outcome that coaches help you with, we don't write your tests. What we help you do is create a culture of quality. We help you create an engineering culture.
Engineering culture, right.
That helps you with quality, that helps you
Because,
with observability. That is using objective data and saying, we understand this now. Here's the proof. If these tests pass, I can, even though I don't understand how the system works, I can prove that we can redeploy. That's very valuable.
And very important to mention, if you reach that point that you actually need help, you have a proof that you haven't implemented engineering. It was just development, right? So you're just, rush, right?
Yes, right. And if you end up doing this, then just by having the culture, you will then end up doing all of those things we already mentioned. You will cover boundaries with dependency and contract tests. You will cover critical user journeys with integration tests. You will cover new behavior with the dev tests. You will immediately start outside in with smoke tests. And you will pair program with the product experts so that you increase your level of understanding to maintain the culture of high quality excellence, of observability, of just having data-driven processes in your engineering department to actually do engineering rather than just coding, rather than just CFO-driven coding. Because what Adrian just said is actually what I have in the slides. If your tech and business leads are not giving you enough time and autonomy to manage your quality and scope, then it sounds like you're a feature factory on a death march. Rush, next, more.
Survival mode.
Survival mode.
Let's take a look how long can we sustain that, right?
The arrow inevitably points back to where we started. Are the authors of the current system still on the team? People will leave. That just repeats the cycle.
This is what I mentioned beforehand. On some point, the only way to stop that is to actually go away. Because this is not a single person's decision to fix that. Even though if the CEO or CFO is giving you permission to do that, the others needs to be willing to do that as well.
It needs vertical buy-in.
It is
business side.
It is hard to do that. It is really hard. We don't talk about a little website here and there. You know, we're talking about especially legacy systems. Are very, let's say, special. They are very handcrafted and unique, which means that
they have a culture. They have a culture.
They have a culture. So there is a high chance that they don't have engineered systems in the past because let's be honest, in early days of PHP and C#, ASP.NET, this was a colorful mix of practices we did back then. And it is, if you have a system which is up to modern standards and programming principles and engineering principles, that's actually that's winning in a lottery, right? That's you don't have that, and it's totally fine, and no one needs to be ashamed for having. I have those systems created, right? And I'm still paying off the debt for them. But the point is, I do in awareness. So what I want to add to this one, this is first of all a very great bingo thing you have just done there. I want to add something, and this is the awareness and the understanding. You call that create a culture of quality.
Yeah, so that's down here. Yeah.
Right, but I call that being aware. So you weren't aware of those things.
You quote art, the war of art, right? So this is the going pro moment. Right?
Exactly. So you say never again. You know it will happen again, but in that moment you are aware of and you do something against that.
Yes.
Right? Even if it's not 100% every day, but it is constantly doing something against that, and constantly adds up to a lot, right? And this is what we all need to think of, and this is how life works. If you save every day in euro for the next 10 years, you have quite a lot of money at some point, which doesn't cost you quite a lot, in comparison how you would get the money in 10 years just in once. And this is the same with a system like that. If you put a little bit of effort every day into your system, then it's already great. So this is now, don't get me wrong, but it is not about doing like being the perfect engineer, having the perfect engineering team, everything is perfect, like textbook perfectness. No, it is not like that. Do it, be aware of it, and especially do the things which are really painful and start with those. On some point, your mindset will change, the team culture will change, inevitably, the skill set will change, and then you can't think of a way of working like in the past anymore. And this is the real turning point moment, when you really cannot stand the old way anymore. And this is where you actually have made the leap.
And I'm not saying you need a coach, like an outside coach. You can just start with somebody in the organization who wants to drive a culture of quality and confidence, and quality and observability. And sometimes this happens by you hiring a new CTO. Sometimes it happens by you being acquired and they audit you, they do technical due diligence, and they say, guys, you need to fix this and this and this. And then you have outside pressure, top-down support that, hey, this needs to be fixed. And then you can do this internally with everything you have. But sometimes somebody finds themselves here on one of these, and then they go down this route backwards, so right to left, and then they realize they get scared, observing that the team just keeps doing this loop ad infinitum. They just keep doing this loop, and whoever joins the team gets sucked into this vortex, and they keep repeating the same mistake over and over and over and over again. So if you're not starting from here as a business stakeholder like CTO or a VP, if you start somewhere here, that is then also where a coach can help. And usually that's the difference between my clients and your clients. Your clients are usually CTOs who want help with this, want support with this, and just want to have a second opinion on it. My clients are usually AMs who are tackling, let's say, 3 of these for one of the teams, and then they say, I don't want to repeat this cycle. I want to break out of it, and I want this, Dennis. I'm sick of people not being confident deploying. I'm sick of people not knowing how to test. I'm sick of people being scared to test. And then inevitably it leads down to this lack of trust into engineering, which creates more control, more transparency, more micromanagement, more push, rush. And then people leave, and the next generation repeats this cycle. That's what hurts. That's what drives companies out of business if they are successful. Because then they go down the wrong path, and somebody has to go pro. Somebody has to take this seriously. If you don't have a culture of investing time into tests, into quality, into observability, into data, into having pipelines, you will create a culture where you will have to do everything 5 times, 10 times.
And when you have,
things will start falling apart.
when you have reached this point where you realize that you turn pro in that sense of software engineering, this is some like a new, you count you start to count the years of engineering from that day on, and not from the days before. It's a little bit like pre-pro, and exactly it is and you can then see everyone else who's still in the old world. You can actually see them from 100 meters away, and you realize everyone else who is constantly pushing forward. Because one of the big differences between the people who are aware of those things, who work on those things, they are constant learners, they are open-minded. And you see many people who are very defensive, very reactive on those things, and say, no, we did that way, and we try to find, they like to be the hero saving the day in the deathmatch area. That there are actually people who are thriving there in this red corner. And this is something which really, I hate that, because I as CTO and employer, I know what I'm talking about. Those people exist, and those people cannot turn pro because their mind is not wired to that. And this is the point.
They are conditioned to be very efficient and risk averse in that death march loop.
Yeah, and this is not good. But yeah, I don't want to start too much about this topic, but you can, yeah, you can, yeah, actually, you can, determine a person by knowing how they behave in terms of those things. And if you have a team of, let's say, open-minded people who discuss together how we can solve those problems, you are actually on the lucky side as a team, as an employer, as CTO, engineering manager, whatever. And oftentimes, engineering manager, CTO call for help. The point is that they don't need help. It is the entire team which is not working, the culture which is not working. And if you have oftentimes the dominant, and this is very problematic, when you have dominant people, oftentimes called toxic as well, because it's a symptom of that. But if you have exactly, you have dominant people who seems to be the best people on your team, but they're doing that in the old way, in the closed-minded way, in the hero way. And this is what you need to tackle first. Get those people somehow aligned or out of your company. I can openly talk about that. There's nothing in between. Either you manage to get this person onto the side where everyone is actually getting some positive effect from that, because this is about culture, this is about quality of life, this is about salaries.
It's usually a culture that lacks psychological safety, because there's this underlying premise of, I don't want to be seen to fail, so I will do everything that is necessary not to fail. Because if you've read, for example, the software engineering handbook by Google, like software engineering at Google, the SWE book, if you Google SWE book, you'll find it. You'll see that one of their core tenets is don't be a hero, right? So, because what happens if you're a hero? If a server needs weekend heroics or after hours heroics to keep alive, you will keep it alive, and now you'll be the only one knowing that this is a problem, and you'll be the only one knowing how to solve it, which means that you are now the boss factor here. So what should you do instead? You should let it fail publicly, so that you have a need to call a post-mortem, a blameless post-mortem, and then once the team is in the room and everybody's attention is blamelessly on it, you create an environment that is psychologically safer than what you were in before, and you can say, okay, what do we need to do? Why did this happen? What went wrong? How do we prevent this in the future? And then by letting it fail, you get to do the post-mortem, where you actually get all of the team involved to break the cycle. If you continue doing the heroics, you'll just end up rewarding the hero, and you'll only be wanting to recruit heroes who will do after-hours heroics. That's how you create a toxic work environment. That you only want to employ people who do heroics on weekends and after hours for free and when they're on vacation. Because you don't let systems fail, so you never do postmortems, so the team never gets to gather around something, an incident, to gather data from it, to learn from it, and to suggest an alternative course of action so that the heroics don't need to happen. That's the hard part. That's the difference between being on that death march loop and somebody in the organization saying, no, this has to stop. We need to go pro. We need to eat, regardless of what step we're on, break out of it, get whatever is appropriate for our level, and then use that as a stepping stone to create a culture, an engineering culture of excellence, of quality, of observability. So today you learned the 7 types of tests that are practical to you. I've given you some new names to play around with. We had an amazing, funny little bit at the beginning where everybody was doing jokes about what an integration test is. We looked into a few code examples of what the integration tests are, particularly the differences between contract and integration and backend and front-end integration, because there are overlaps on it. We managed to avoid most of the texting hierarchy pyramid bullshit thing, which I'm very thankful for. And I really enjoyed this last 20 minutes now with the legacy system bingo, because this touches at the core of why I like coaching, because I like helping leaders get their team get their organization out of this.
So it's all about the testing pyramid. It was all about the testing pyramid today.
I'm done. Thank you for being with us today.
You need to have some kind of image in the background with those layers.
Stop. Anyway, shout out to our community. I don't know. I think we stopped posting events there, and it's mostly the after show coffees there, which I think makes sense.
We should rethink that openly, maybe with the community together, how we manage that in the future, because we need.
It doesn't solve a strong need.
Maybe we need
right
maybe we need to solve that problem a little differently, a little bit more open, less closed community. Let's have a chat about this, and let's ask.
Let's talk Monday. So, enjoy your weekend. If you would like coaching from any of us, strategy, Adrian is your guy. If you want practical help in getting out of the death march, call me. LinkedIn is best. Our newsletters have particularly positioned sort of engineering manager versus strategic verticals on content. If you want to passively consume content, that's also fine, and you want to take this at your own pace. Let us tell us your situation, tell us your stories. We would like to help you if possible on stream. That's the least bit we can do, and maybe it will get a conversation rolling that will help you have your turning pro moment and improve your engineering culture, because that's why we're here. We're talking about our tech journey so that you can improve your tech journey. I had a lot of fun preparing this presentation, so I will give you the link to the Excalibur drop if you want to export it, and my newsletter post with a recap for this will cover all of the relevant links.
What is next week on Thursday?
I think Jonathan is finally freeing up next week, and Thomas mentioned that he wants. Oh, Thomas, by the way, Thomas won. I just didn't know. Thomas 𝗍𝐼𝐻𝐜𝐿. Thomas suggested today's topic. Thank you, Thomas. You've inspired me to have this conversation, so this is on you. Thank you so much for giving the spark. And next week we'll probably be going into a little bit more TD topics, but I need to check with Jonathan. We'll meet on Monday. We'll definitely announce on Monday what's happening. This was fun. Adrian, thank you for joining me. Hope the meeting went okay. And
It was good. Let me test this one. Yeah, it does work now. Finally.
Terrible. At least it's not a pyramid.
Does it actually work? Hold on a second. It's not working. Pyramid.
That's some Illuminati bullshit. Okay, it's time we stop.
I had my meeting, about pyramids. I don't know, with an I inside it. No, let's go.
I need to go. This was lovely. Thank you so much. Thank you so much for all your support. Thank you for those of you who are stayed with us here after almost 3 hours. Streams keep being longer and longer. A little bit of elevator music for outro. And we'll see you next week.
See you then.
Ciao.
Bye-bye.